So we talk about vector calculus. So what's going to happen? We're talking about the position of any particle, but instead of calling it x, what are they going to call it?
P.
They're going to talk about its position in the I direction and its position in the J direction. And what are we going to do when we differentiate that? What do we get? Velocity. And when we differentiate that, what are we going to get? Acceleration. So it's like pulling it into two parts. The vertical, let's just look at its vertical position. Let's look at its horizontal position and its vertical position. Let's look at its, and let's make up a question. Ready? Now, here's what happens. People do things like, say, 5t cubed. The trouble is, what happens with 5t cubed?
15t squared.
The moment you get to, say, 10, you're at 1,000 times 5, you're already at 5,000. So if I started trying to draw a graph on this, we're already out here at 5,000 after 10 seconds. Yeah. So can you see, we start with simplistic cases that go berserk. So what if I made it a t squared? Yeah, so by 10 seconds I'm at 100 by 5, I'm not at 5,000 anymore, I've got 500. That's a bit more reasonable, isn't it? It doesn't go too berserk too quick. What if I made it I don't know, pick a number like a 2. So it'd be out there at 200 by the time we get... Now we don't care what happens after 10 seconds, we just want to see what happens in the first, say, 3 seconds. Yeah.
So if it's squared and once it gets down to acceleration, there's not going to be a t. So does that mean it has constant acceleration, or is that right?
That's right.
Okay.
I love it. You're thinking ahead. Now I've got to be careful of over teaching it, but I think I've got to over teach a little bit. I don't know. Never taught like this before. You're looking tired too. But you always give me a smile when you're tired, which I like. And let's say we made this one and we just made it, I don't know, 3t here. Pulling up any numbers, 3t plus 2. And I call that j like that. So if we differentiate that, that's going to become 4ti, and that's going to become 4i. That just becomes 3, and that becomes nothing.
Oh.
So the question I just made up is going to have an acceleration of 4, and if we were talking about, say, metres per second, it's accelerating at 4 metres per second every second.
It has a direction.
But just in the I direction, so
Yeah.
Let's find out where it was to start with. So that's what we talk about initial. Yeah. We want to know where it is after 1 second. We want to know where it is. And I want to go 3. But you know what? I don't need to. By the time we do 0, 1 and 2, you'll get the message. So we've got 0, 1, 2. Let's make it nicer. So I've got time is 0. Let's spread it out. 1 and 2. And I can draw up the table. Look what I'm going to do with this table. So RT, we want that. We want VT. We want that. And we want, what's really going to call speed. I want that. Because once you get velocity, they can ask you for the speed. And I can get the acceleration over time. So ready? Where was it to start with? 0. So that's 0 times by 2. 0. So it's at 0i. I'm going to write 0i for a moment, just to be fussy. And it's at where? 0. This thing's going to start at 0, 2. Let's make it reasonable. I don't know. We made that 10. It's going to go berserk, isn't it? How berserk is it going to go though? So it's going to start there. Yeah? Done? And what's its velocity to start with? So its velocity, that 0 is, that'll be 0.
just 3. Was it?
That's 3. What is that?
3j.
3j though. So could I have written that that was 0 plus 3j? So when time was 0, what's its velocity?
3 up.
So it's moving, it's going up at 3 metres per second. What's its acceleration? Oh, what's its speed, by the way? Remember, that's the square root of 0 squared plus 3 squared, which is the square root of 9, which is just 3. So the speed, when it's vertical or horizontal, the velocity is the speed.
Mm.
Had you thought that through before? But the moment I do this, let's say I'm going across 3I and I'm going up at 1j. That's my velocity. My velocity is 3I plus 1j. What's my speed?
Root 10.
Root 10.
It's
Yeah.
just the magnitude, yeah.
Why is speed the
Because
magnitude?
there's no direction of it, right?
Oh,
The speed
oh,
has no velocity,
oh,
has
I
no
see.
It takes a while, doesn't it? So I could just rush through and go, yeah, got it all. But then they'll test your understanding and then you're gone. So speed is the
Magnitude.
magnitude,
Of
Not-
velocity.
the magnitude of the velocity. So you could write down that speed is the magnitude of velocity. So if they ask you the magnitude of velocity, you do that. So then when I think of magnitude of velocity, what do I think of? Pythagoras. So then what's his acceleration?
It's just 4.
Just 4. So in other words, it's accelerating that way at 4. And I've got no scale. I've got a 200 over there, so I'll leave a 200 on the scale. Probably don't need 200 at this stage. Turn it back into say a 100 or something. So that'd be 50 and we can go, where's the others? Okay, so what happens after 1 second?
Oh, then it's going to be 2I plus
3 1s
5j.
are 3 plus 2 plus 5j. So its position will be, I'm going to work this out now, that'll be about there. Try to be a reasonable scale. Is that reasonable? So its position now is 2I plus 5j. So about 2I plus 5j, now it's there. What's the velocity? We're going to put in 1, so that'll be 4I plus 3j.
Oh.
So now its velocity is 4I. So that's the one you're heading, isn't it?
Yeah.
So at this point its velocity is going 4 that way and 3 that way. So its velocity is now that way. That's its
Oh
velocity.
no.
That's velocity up at 1. That was the velocity to 0. Now we've got its velocity.
Does it make like a curve?
Yeah, so what's going to happen to this thing? Let's go back to here. That was its position. Let's finish off for a moment. Speed then is, that was nice. We fluked it. 5. I didn't mean for that to happen, so that's nice. So that's, I could write for the sake of if you're watching on the video, that's 4 squared plus 3 squared, which is root 25, which is 5. By the way, if you notice when we do that, we've got no i's and no j's, because speed doesn't have i's and j's, it only has a number.
Yeah.
Okay, so then what would A be? For A for 2, it's irrelevant at time. So by the way, I could have made this a t cubed,
And then it wouldn't be.
then it'd be
Constant,
changing
yeah.
all the time.
What do you think? No, no.
And now can you see those in the moment, in the next, later on, we're going to get onto circles and all sorts of things. You're right? Because what happens when you have parabolas and cubics? Faster, 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 off they go. And if it's cubic, you're like, on the way they go, I'm being a idiot. That's too over the top. Okay, so that's going to be 4i still. So do we want to graph that? Nah, I don't think so.
Surely.
It's just going to end up being like flat in that direction because the acceleration is always.
Yeah. You saw it in the first place. But then you don't trust what you see in your head, you know. So last bit, we'll just go 2. So that'll be 4 2s, that's 8i. And then it's going to be what? 8j, isn't it? 3 2 is 6 plus 2
Whoa.
is 8j. So next, 8. So I could have done a bigger diagram. I mean, you know, a different scale. I've turned it now into this tiny little thing. So I should put in, say, 5. But you've got the picture now, haven't you? So at that point, what's the red? The velocity is 4 by 2, which is 8i,
Oh. So
plus 3j. So you could look at it and say the 3j's are the same all the time, and these are going up by how much? By 4. So these stay the same and these go up by 4. They stay the same and they go up by 4. So it's a really simplistic case of it again. So that one would be the square root of 8 squared plus 3 squared, which is 64 and 9, 73. That's its speed. Different to velocity. It's the Pythagoras of the velocity, and that's a 4i. Do we need to go further? My brain wants to just for a moment do this. Tell my brain to stop it, will you? Let's just
Don't
go,
stop.
go to 5. So 25 by 2,
50.
thank you. 15 plus 2, 17J. So now we're at 50I, so there's
So
50
yeah, you're just flattening out.
plus 17J, and you start to get the message
So
like
just
you
like-
said.
It's super flat.
There it is. Could I change it from this form into Cartesian?
Probably.
What do you expect that's going to probably be? Square of a graph? Part of a parabola?
It could be the. Ah.
So if we looked at the x component, the x bit is 2t squared. What's the y bit? 3t plus 2. And that's called the parametric equation
Is that Cartesian?
of that. And how do you get rid of the t? Starts with s and got 12 letters, doesn't it?
Substitution.
Substitution. So I could go, well, I want to go 3t equals y minus 2, t equals y minus 2 on 3. I could do that, couldn't I? And this is x equals 2 times y minus 2 on 3 squared. Bit yucky,
Gross.
but so what do we got? 2 outside of y squared minus 4y plus 4. Are you quick enough to do that these days? Y squared minus 2y and double, it's 4y minus 4y minus 2 by minus 2 is 4. So, okay, so what do we got? So we know the y squared was that, and then we got 3 3s and 9. So we've actually got 2 ninths of y squared minus 8 ninths of y plus 8 ninths. What's that called? Starts with P.
Parabola. So it is the side.
So it's a sideways parabola. So the
Small
x's become
step.
y's and the y's become x's. So we've inverted a parabola from this way across to that way. Inverted,
Which
reflected.
is the functions.
Yeah, inverse functions. So we talk about inverse functions or reflected functions.
Oh.
So all we were doing with that is a parabola anyway. Yeah?
Everything we've ever learned is
Yeah.
suddenly coming together.
Yeah.
This is
So-
chaos.
So imagine the questions they could say to you. What was the velocity of this particle after 3 seconds? And then they put in trigonometry. And then they say, what was its speed after 3 seconds? Pythagoras. When was it at, what do we have for that one? When was it at 8i plus 8j? And on you go.